Hello everyone, I'm Dr. Mingo Park in charge of training for utilization of fumigation equipment and devices in QuickCar program. In this time, I'm going to present making a standard gas for gas analysis as the last lesson. I'm a team manager of phytosanitary treatment in pest control division in Animal and Plant Quarantine Agency. I made a presentation in following order: 1, about standard gas; 2, making standard gas; 3, calculation of gas concentration; 4, conclusion. This is about standard gas. When we measure distance or length, we need a scale ruler like this. Then what is required to measure the gas concentration? Commonly, gas concentration can be changed during fumigation because of absorption and leakage. So, concentration monitoring is important to achieve the successful pest control pest control. When we can use gas chromatography to monitor the gas concentration, but this only represents the relative value. Standard gas is kind of scale ruler for calculating the gas concentration. Making a standard gas is the first step of gas concentration analysis. Like a scale ruler, each standard gas can be act like a graduation. If we already know concentration of gas, we can assess the GC value with gas chromatography. We can draw ruler which represents the relationship between gas concentration and the GC value. And we can calculate the unknown gas concentration with this ruler. This one is unknown gas concentration, but you know that the GC value. Like other scale rulers, concentration range of unknown sample gas should be distributed between standard gas range. So we can calculate this unknown sample. The sample should be inside the standard gas range. Making a standard gas is simple if you know how to handle pedal bag and syringe. First, calculate the volume of gas for each standard gas. The gas equation is as below, this one. Input concentration and volume of tether bag in the equation, then you can calculate the volume of gas. But we can inject approximately for easy measure. This is a real inject dose. At that time, we should also calculate real concentration by approximate injection volume. Second, inject the calculated dosage of gas into air-filled tether bag. Like a phosphine or metabolite, most fumigants form it into gas at room temperature. Inject the gas form fumigant is as below. Inject the air of 1 liter in tether bag. Like this. and remove the volume of air as much as the calculated volume of gas in the bag. The calculated volume of gas is calculated in this Excel table, this one. Almost 5 milliliter removed. It's removed. And then you should work in fume hood or well ventilated site when you calculate the amount of fumigants with the gas tight syringe, and then capture the gas into tunnel bag. Okay. The slightly low at the bag for mixing. However, some fumigants like ethyl formate form into liquid at room temperature. So injecting the liquid form fumigant is as below. It's a very similar procedure as at the previous slide. You capture the air of 1 liter with the jumbo gas tight syringe. And inject. And then you remove the calculated volume of air from developed bag. The volume of air should be identical with the volume of vaporized fumigant, not liquid form. Okay. And they calculate the amount of fumigant with the liquid syringe. You can calculate the volume of liquid ethyl formate like this, by dividing the dosage by density of by the density of liquid ethyl formate. This is from the lesson of use of small fumigation chambers for disinfection test. You can see the details in that lesson. capture calculate the amount of fumigants with the liquid syringe. This is Excel format. Inject capture the liquid into tether bag. And wait until fumigant is evaporated. That's why we have to remove the air volume. This is a calculation of gas concentration. After making standard gas, analyze standard gas with gas chromatography, then you can draw a linear graph by fumigant concentration and GC value. This linear graph is called standard curve. With using Excel or other statistical program, you can also figure out the linear regression equation. This one. From regression equation, you can calculate the concentration of sample gas. If the R square value of equation is too low, then there could be a problem at making a standard gas or GC analysis. So that's why R square should be close to 1. This is a very quite close to 1. So that's why it's very convincible the standard curve. So if GC value of sample gas is 20 during fumigation, concentration sample gas is calculated like this. The concentration is 23.8 gram per cubic meter. And we have to find this X is the concentration. Let's check how to draw standard curve and calculate the concentration with the video clip. We determine the gas concentration. And then we assess the gas GC value with the gas chromatography. We can draw the standard curve like this. And then we also make standard curve and the equation. Yes. So we have unknown concentration. We have unknown sample. So with this equation, we can calculate the unknown gas sample. So we can figure out concentration. Like this. Then we found the S. So the equation could be changed. Y minus 0.4 divided 0.822. Okay. And so we finally found out the concentration during fumigation or after fumigation as well. Conclusion: standard gas is kind of a scale ruler for calculating the gas concentration. So making a standard gas is the first step of gas concentration analysis. Before making a standard gas, check the form of fumigant at room temperature. You have to use a different method to make a standard gas by form of treatment, form of fumigant. All procedure should be performed inside the fume hood or well-ventilated place with wearing a gas mask or other safety apparatus. Thank you very much. This lesson is the last lesson for me. Thank you so much for listening my lectures. I hope it will be useful for you all. Thank you.